Okay, now we start talking about exponential smoothing methods used for forecasting based on time series data. So we know basically for business analysis, especially when we talk about forecasting, business data normally they're time series data. It's recorded what other people call historical data, like sales values in last 10 years, so annual sales values, annual total revenue, total profits, or daily stock closing prices, or these kind of things. Normally they're indexed by different time periods, different days, different months, different weeks. So in that way, if you plot the data for most of the time series data in business world, normally they show some kinds of patterns. So most important patterns, we say there are two most important patterns. First is a trend. So for a business time series data, normally we are expecting, also we are observing that total sales values, normally they are increasing over different years, over the last 10 years, over the last 20 years. So in that way we say there's an increasing trend. Also there's seasonalities. Normally for sales values, especially for large supermarkets, for like JCPenney and for Macy's, for Dillard's, for Bloomingdale's, all these different shopping malls, the supermarket, normally you will see the sales increase in the shopping seasons, or we say in the fourth quarters, or in December, in January, normally we see sales increase, but also in other months they will decrease. So all these kind of seasonality patterns show up. Right now we are talking about how if we only have the sales value, we don't observe other independent variables. So in that way we say if we don't know any other independent variables. So normally people will think that it's impossible to run a regression model to predict the sales values, our dependent variables, or the variable we are interested to analyze, to predict. But later on, we will talk, after we finish talking about exponential smoothing methods, we also will discuss how to create dummy variables and create trends variables to capture these kind of patterns. If we want to use a regression model, still we can use regression model. But right now, let's first start talking about exponential smoothing methods. The simple exponential smoothing methods is listed in the formula here. It just says that the predicted value for each time period, it's based on the level estimate for the last time period, L sub t. And this level estimate is simply, it's a weighted average of what was really observed. Like say if Y here denotes stands for the sales values we want to analyze and want to predict, then what really observed in this time period, Y sub t, and also including what was the estimates for the last time period's level, this L sub t minus 1. Also this LT sub minus 1 is the forecasted values for Y sub t. So let's say this weighted average is our updated estimate for the current period's level, L sub t, and we use current time period's level estimate as a forecast for the next time periods of Y. So remember Y sub t plus 1 hat. This Y hat simply tells us it's a prediction, it's a forecasted value, and the subscript tells us this is a time index. So in that way, alpha here is a smoothing factor, it's a parameter. It can only takes value between 0 and 1. So okay, based on this model, we say to predict into the future, because we are not only interested in how to update our estimates based on historical data. Also, most important is we want to predict for the sales value. Let's say Y is sales value. We want to predict the sales value in the next time period. So here t plus 1, y hat sub t plus 1 is a forecast for the next time period, t plus 1. And it's based on our estimate for the current time period's level. That's one step ahead forecast. And into the future, because we only observe real sales value up to current time period t. So we only have this y sub t here. So into the future, based on simple exponential smoothing method, we keep using the most recent level estimate. So if one step ahead forecast equals L sub t, 2 step ahead, 3 step ahead, they're the same. We keep using that. So if come back to Excel file, low length, which was uploaded in the Georgia View in the online account, you can download. So let's say for TV sales, in this time series data, we say whenever we want to do the time series analysis, first thing is to plot our data, to get a time series plot, to see whether there's any kinds of patterns, to identify any potential patterns embedded in this time series. So from here we see there's no obvious trend. It varies, looks like within a combined range from 30 to 40. So also there's no obvious seasonality, that there's a fixed pattern that repeats itself over the same length of time period, like every week, every month, or every year. So in that way we say because there's no obvious patterns of trend and then obvious seasonality exists here. So in that way we say maybe we think simple exponential smoothing method, this model is more appropriate compared to other exponential smoothing models. And to update, let's clean this one. Based on this model, we say if we want to update our estimates, we update from the first time period t when t equals 1. But based on this formula, this model, we know we need an L sub t minus 1 when t equals 1. That means L sub 0. We need 1 initial values. So initial level, because based on exponential smoothing, as we discussed in previous lecture notes and also in the textbook, the exponential smoothing method captured all available historical data into our forecast, into our analysis. But the inference from the initial level will decrease exponentially. Its inference is decreasing exponentially. So if we have long enough time series data, if n is sufficiently large, even here we only have 24 months, so n equals 24. The inference from initial level will be ignorable, will approach 0 inference. So in that way, normally it doesn't matter what you assign to the initial level estimate. So you can use historical mean level, or you can even use simply set L sub 0 equals the first observation. Another important thing is the parameter value. Alpha is given. So when we update our simple exponential smoothing model, update our level estimates and forecasting, in these updates, if you check the formulas, within you will see this L3, the alpha level, we put $sign before the column index and the row index. That means we fix its value. It will not change if we copy paste into different cells. But later on we will say also, you can, after we finish updating our model, you can change the alpha levels to see which alpha give us the smallest MSEs. That alpha maybe it's more appropriate to keep using, but that's another way. you need to conduct a sensitivity analysis using data table in Excel to check its inference. So here let's see how to update that. Based on this model, let's first delete all these things. So always, it doesn't matter where and how you establish or you structure this model in Excel, because different people prefer different structure. So here always the formula are the same. So keep using these formulas. That way the level estimate, we say it's a weighted average. It equals alpha times, but this alpha is fixed over different time period. So whenever we link to this one, you press F4 key. So it will put $signs before both the column and the row index. It times what really observed in the current time period plus 1 minus alpha times the last period level estimate, which is also the predicted value for the current time period. So we update our level estimates for time period 1. The forecast for time period 1 for this time period simply equals the level estimate of last time period. The error of our forecast simply equals the real observed sales minus what was predicted. And here we like to also put the absolute errors, and then we like to take the square, which will be used to calculate the MSEs. So okay, after we finish updating these things, you check the formulas to make sure in these cells they are calculated correctly. Then you double click. So over the whole range from time period 1 to time period 24 here, level estimate forecasting will be updated automatically. It's simply like if you highlight this one, you drag over the whole range. It's the same. Simply copy paste the same formulas in the first row, in the rows for the first time period to the period of 24. But then we say more important, we want to predict into the future. So one step ahead forecast in this cell is simply equals the level estimate of the last time period. And the 2 step ahead, using the formula, it equals the same one here. So 3 steps ahead also the same. So now we finish the simple exponential smoothing model. And of course, if we want to conduct a sensitivity analysis to see how these MSEs change according to the change in different alpha levels, different smoothing parameter here. So you can use a data table, one-way data table in Excel to conduct sensitivity analysis. And another way here in the example I post online, you will see the MSEs. I just simply take the average of the squared error terms. So more precisely, this is not correct, because we know MSEs is divided, it takes the summation of those squared error terms, then divided by n minus 1. But here we are simply using the summation divided by n, because normally in time series analysis the n is sufficiently large. So if it's a stock daily stock closing prices, normally you can observe the last 10 years. So that's more than thousands different data. So in that way, divided by n minus 1 and divided by n doesn't make big difference. So there's no significant difference between which value you are using in the denominator position. So here we say we just simply using the average. But if you want to compare with a regression model, later on we will talk. If you want to use a regression analysis to analyze and predict based on time series data, then in that way the MSE used in regression analysis, we know they are using the denominator values divided by n-1. So we need to modify that. But if we are talking about exponential smoothing here, we can simply take the average. So it's more convenient to use. Okay. So based on that, if you want to using an overall plot, based on retrospective on historical data to see how your model perform the prediction. So we'll see the predicted TV sales is a smoothed sales value, although it doesn't capture the variation more closely in that way. So okay, now let's discuss another time series here, which we want to talk about the trend issue. So for the CD player sales, if we first obtain a time series plot, which is a plot of sales values over the whole time horizon here, so we'll see there's an obvious upward or increasing trend. So in that way, if we use a simple exponential smoothing model, because we know in that model the assumption is that there's no other patterns exists in time series, then that model is not appropriate to use. If you want to use that, that's okay. And I think I posted another example in Excel here. The Acme Tools company sales. I use the same time series. I try to use the trend exponential smoothing and the simple exponential smoothing. You can see the MSEs, if you use simple exponential smoothing, when the trend exists. So here, this one, if we include trend, it should be much smaller than if we ignore the trend issue. Okay, now let's see how we update our estimates for the level, and also we need to consider the trend issue. So always check the formulas first, how the model tells us. So this trend adjusted exponential smoothing model, also people call it the Hodge linear trend method or Hodge model. In this way, we update our estimate for the level, which also including the consideration of the trend issues. The updated trend estimate for the last time period, and also the level estimate for last time period. We sum them up and consider this one and with what really observed in this time period, the y sub t's. Take the weighted average using the same smoothing parameter alpha. We denote this one, still use the same symbol here, alpha, the Greek letter. But also we want to update our estimate for the current time period, the capital T sub lower letter t. This one is also when we update our estimate, we also use a weighted average formula. It's a weighted average of what changes in the levels, in the level estimates. And also we consider what's the trend estimate conducted in the last time period. Now we use weights which denote with another parameter. We call it beta. So the formula is listed here. Right now there are two equations. We will not only update the level, also we will update the estimate for the trend. So in that way we see to start updating, we need not only the L sub 0, also we need the initial trend estimate, the capital T sub 0. So we will see how in Excel we update these estimates. So initial level also estimate, we can use the historical mean level or use other values, which is a reasonable figure. For smooth trend, also you can use the first 6 months. The increasing trend takes the average, or simply sometimes if we have long enough time series, here we only have 24. If we have like over 50, over 100, simply you can use 0. So normally say we just assume there's no trend from the beginning. Then let the data, let this model, this hot exponential smoothing method to capture the trend. So that's no big difference if we have long enough data time series. So here we just use a arbitrary value 2.73. And alpha and beta parameter values are given. So assume they are fixed here when we update our estimates. Same as previous. Later on, after we obtain the MSEs based on these absolute errors, take square, then we can take simple average or divided by n-1. Then we want to see how, when these alpha and the beta parameters they change simultaneously, how your MSE changes. So in that way, because there are only 2 parameters, we can use two-way data table to conduct the sensitivity analysis. But that's another topic. So let's to see how we update these estimates. So let's first delete it. A better way always to play with examples posted online to check the formulas within these spreadsheets until you totally understand. But important thing is to type into those cells the formulas in correct way. So here we see similar to previous simple exponential smoothing method. It's a weighted average. The weights is measured in alpha and 1 minus alpha. So these are fixed. Press F4. It's not changed. And also regarding the real observed value in this time period. Right now we are in period 1 in the first month. So plus 1 minus alpha. We fix this alpha level times, not like previously, simply the last time period's level estimate. Right now you should consider the sum of level estimates conducted in last time period plus the trend estimates provided or updated in last time period. So the sum of level estimate and trend estimate conducted in last time period is simply the predicted value for the current time period. So this is based on the first formula here. To update the trend estimate for the current time period, we know right now we use beta and 1 minus beta as the weights. And in regards to the changes in different levels, these are the changes in the trend. It captures the dynamic changes in the sales value. And also it relates to what was estimated, what was updated in last time period for the trend estimates. So if we come back to here, it simply equals the beta estimates times the changes in the level for different time periods, and plus 1 minus this beta. Also never forget to fix this value by press F4 key. times the trend estimates from last time period. So after that, press enter. For the forecast, based on Hot's linear trend model, so based on trend adjusted exponential smoothing model, the forecast for the next time period always equals the summation of the level estimates and the trend estimate conducted in the current time period. If we want to predict into the future, then each step ahead, h equals 1, 2, 3, 4, up to a sufficiently large number if you want to predict into far away into the future. So here we see it also simply we use the most recent available level estimate and trend estimate, because in next time period, right now if we are in month 24 based on this lowland company sales time series data, because we only observe the sales values up to month 24, up to the end of the second year. We don't know what really the sales numbers are for the next month. So in that way, we cannot update our estimates using these formulas for the level and for the trend. So we keep using the most recent updated values to predict into the future. So that's the logic behind it. So come back to here. For the first time period, it simply equals the summation of the level estimate and the trend estimate from the last time period. So error term simply equals the difference between the really observed sales values and what was predicted sales values. So absolute value, you simply use the absolute functions in Excel. So after we update our estimates and type in the formulas correctly, then you can copy paste into the whole range. So we'll see into the future. So the next month, let's say in January for the next year, because we don't observe anything yet. Suppose right now we are in December of the second year. So January of the third year, it simply the forecasted CD sales values simply equals the summation of the level estimate and the trend estimates update in this December. And for next February, we keep using the most, we keep using the most recent level and the trend estimate. But right now we assume the trend is kept constant. It's increasing by the same amount over different months. So here, that's why we use 2 times the trend estimate. So if for the next March, then simply it equals the most recent level estimates plus 3 times, because there are 3 steps ahead, the most recent trend estimate. So that's the logic behind it. Now if we come to seasonality, because like previously we discussed for sales values, normally also it contains seasonality. So we will use the Winters method, or more specifically, some statisticians like to call it trend and seasonal adjusted exponential smoothing model. So we simply call it Winters model. So this is a model here. It contains 3 equations. the systematic equations. So use these equations, use this model. When we update our estimate for the level estimates, looks similar to the HOTS model, but we must adjustify these estimates. Adjustify by seasonal factor. If it's monthly data, then S equals 12. If it's quarter data, S equals 4. So adjusted by seasonal factor for the same season in the last year. Here, if we assume it's sales value and we measure them, it's monthly sales data or quarterly sales data. So we see in the last same quarter or last year same month. And another part here is the same as a HOTS model. And for the trend estimate, there's no change, using the same formula. But because the level estimate changes, so also it will change automatically. In Excel, the attractive things in Excel is that if we assign those formulas and link all those calculations to as less parameters or as less changing cells as possible, then it's easy to update the estimates by changing only a few sales values. So here, right now, we introduce the third parameters here, gamma. We say that for the seasonal factor for the current season, for this season, it's updated. Also, it's a weighted average. Updated, it's considering what really changes in the sales value observed and consider divided by the level estimate for the current time period. And also, it consider what's estimated the seasonal factor based on last year's estimates. So the smoothest seasonal factor S sub t, it's a seasonality estimate. So normally in business time series data, we will see the monthly sales values or quarterly sales values. So most commonly we will see S equals 4 or S equals 12. But of course, if we just analyze the weekly sales value, like say for McDonald's retail store sales, then we will see a weekly data. So in that way, we want to, if we are analyzing the daily sales values, so definitely Monday sales values, it's different from the Sundays or Saturday sales values. And also, if we are interested in different hour sales for different days, then definitely in the noon time, like 12 o'clock, the sales will be more than the sales values compared to the sales number in like 3 p.m. or like compared to 10 a.m. something like that. So that's different. In that way, the fixed the length of time measured, it's in days or in weeks. If we are considering weekdays, different seasonalities. But normally here, let's say it's fixed in years, the annual things. But the logic are the same. And the forecast into the future, if we ignore these seasonal factors, we know they are same as the HOTS model in these parentheses. But we know based on the HOTS model, right now we want to modify or justify these estimates by using a seasonal factor. So for these AC cells, if we plot them, we say always the first step is to obtain the time series plot. So we will see over different years the same pattern repeat itself. The AC cells reach the peak value in the summer seasons, so then it decreases. So the same pattern repeats itself over different years. Here, because we only have 2 years, then it's obvious, but maybe not obvious enough. So let's come back to another data set. For Economic Tools, company sales numbers. So this is the quarterly sales values, the time series. It's a sales value for the last 6 years. Sales value we see every year. The sales reach the top in the first quarter, then decrease. Reach the bottom in the third quarter, then increase again. So the same pattern repeat itself, and over the long run, in the last 6 years, there's an obvious trend. There's an increasing trend exists here. So we see in that way, it not only shows that there's a trend, also it shows that similarity. So we need to use a Winters model to capture both these two patterns. Let's say here, come to this one here. So let's assume we only observe the last 6 years. We don't observe this one. So assume currently we are in the fourth quarter of 2005, and we obtain the sales time series data as a time series plot and the sales values. So to start our estimates using Winters model, so we need not only to update our level estimate, also we need to update our trend estimate, and we need to update our seasonal factors, because right now every year we have 4 seasons. There are 4 quarters, and similar to the HOTS model, to start our updates we need initial levels. Here we say simply set it to the first quarter sales values, and we assume there's no trend initially, so let the data to capture the trend issues. But seasonal factors, here we use the first 2 years quarter sales values to calculate the seasonal factors. So this one is simply, it shows the ratio compared to the mean quarterly sales values. So if it's larger than 1, it means compared to the mean level, to the average quarterly sales values, the first quarter, this is stands for the first one, the number it's larger than the average values, and the third one is the lowest. It only on average it only comes through 64% around, compared to the average quarterly sales values, and the fourth one almost approach the mean average quarterly sales values. Then let's see how to update. First, let's delete all these. And the alpha, beta, gamma, these parameter values are given here. They are assumed to be fixed. So come back to the formulas. Always, it doesn't matter where you conduct your updates, where you type the formulas. Into this model. So always using, because we are using the same model, these equations, they do not change. So for the level estimate in the first quarter in year 2000, right now we assume we are in the first quarter of 2000, it simply equals, it's a weighted average times what's really observed in this quarter, but adjust it with the seasonal factor divided by seasonal factor for the first quarter but in last year, which means then 1 minus alpha times the level estimate and trend estimate conducted update in last time period. So this is the formula. After you type it, always, if you are still not sure, always come back to the formula here to check whether it's correct. So sub t minus s here, because quarter data s equals 4. So t minus 4, because right now we are in t equals 1. So that's 4 periods before. So that's this cell. That's what this H4 stands for. For the trend estimates, it's a weighted average using this parameter. So if you're not sure, then always check these formulas. Beta times the change in the level estimate one minus beta, press F4 to fix it, times the trend MS estimate in the last time period. So that's it. Because initially we assumed the trend estimate is 0. So that's why we obtained a negative value here. Then be careful here is how to update our seasonal factor estimate. So we'll update the seasonal factor for the first quarter again when we observe a new sales value for the first quarter. So the formula is here. It will use the seasonal factor for the first quarter, but it's in last year. Then we check compared to the level estimate how the observed sales values perform. So it equals gamma, fix it, times what's really observed divided by level estimate plus 1 minus gamma times the seasonal factor for the same season. Here it's quarter for the quarter 1, the same quarter but in last year. Here, this cell. So press enter. So that's the updated seasonal factor estimate for the first quarter. So forecasts, we need to take care of the level estimate plus the trend estimate, but updated in last time period. But then again, times, we must modify, adjust this summation by the seasonal factor. So right now it's for the quarter 1. So similarly we say it's times this seasonal factor, because to obtain the forecast for this quarter 1 we assume there's no observed quarter 1 sales value yet. So just keep in mind. That's our forecast values. If you're still not sure, you can compare different models. You will see here, if you double click, you will see always linked to seasonal factor for the same season, here for the January, but in last year. So 12 months before. That's the idea. For quarter data, then it's 4 quarters before. So the same quarter in last year. The absolute errors simply equals absolute value between the observed and what's predicted for the current time period. So square So after we finish typing the formulas into period 1, you can copy paste into the whole range. So also you can check formulas in different time periods to make sure all of them are the same, the formula are the same compared to the Winters model. So okay, to predict into the future, let's see, similar to the HOTS method, we keep using the most recent available, the updated level estimate, and most recent updated trend estimate, and the most recent update the seasonal factors. So we see the most recent seasonal factors for different quarters from quarter 1 to quarter 4 is obtained in the year 2005. And also most recent level estimate, most recent trend estimates is also conducted in the last quarter of year 2005. Here we assume we don't observe the sales for the first quarter of 2006 yet. We simply use this value 850 to check how our forecast model perform to predict the sales value in this quarter. So 2 steps ahead forecast. We know simply using the most recent available, the most recent updated level estimate, trend estimate, and seasonal factor. That's for the second quarter here. So these are for 4 quarters. So if you want to predict into the 5th quarter, 5th step ahead, so that means the first quarter in the year 2007, we use the same formula here, and the seasonal factor comes back to the seasonal factor updated in the first quarter of 2005. So if you want to do that, a simple types in the most recent level estimate plus, because that's 5 steps ahead, 5 times, we assume the trend keeps the same into the future, then times, but the seasonal factors always use the most recent seasonal factors. So that's our predicted sales values for the first quarter of the year 2007. So that's a general idea. So later on we will also, in another topic, we'll discuss how to use regression models to capture this kind of trend and seasonal factor issues, the seasonality issues. So that's all for exponential smoothing models right now.